Hi, Assalamualaikum. My name is Mohamed Hafiz bin Rusdin, and I will present my final year Project 1 presentation for the title of Fluid Optimization of the range of SUNGAI BUNUS via multi-objective evolutionary algorithm. I'm sending my gratitudes to my supervisors, which are Associate Professor Technologist Dr. Zulkifli bin Mohamed and Engineer Hapida Binti Ghazali. My panels are Sir Hanif and Engineer Dr. Irnie. For the content, I will be discussing about the project summary, introduction, literature review, problem statement and objective, scope and limitation, methodology, preliminary results, and project planning. The purpose of this study is to provide a great solution for the community, Department of Irrigation and Drainage DID, and also the government to prevent the occurrence of flood likely to happen efficiently by optimizing the values of flow rates at each online storage systems. A multi-objective evolutionary algorithm method is applied to demonstrate the concept of optimizing the flow rates that plays a part in the operation of the mechanical infrastructure of the SUNGAI BUNUS catchment. The outcome of this study may provide a set of data that can be utilized to operate the pumps gates for improving the monitoring techniques. Flooding happens when a large amount of water surpasses its normal limits, especially over normally dry ground. Three types of flood disasters that have devastated the country, including the flash floods, coastal floods, and monsoon flash floods. In this study, it will focus partially on the Klang River, which is the SUNGAI BUNUS catchment area, and it occupies the northeastern part of the Federal Territory of Wilayah Persekutuan Kuala Lumpur. The approach that will be proposed in this study is optimizing the flow rates from each storage at the upstream, starting from the Tapak Jaya Pond, online storage Suri Rampai, online storage Air Panas, online storage Titi Wangsa, and lastly, they will meet at the downstream, which is available storage of Kampung Boyan before releasing the water to the Klang River. Literature review. Mohamed and Rawi state that flooding can cause property damage and human casualties, as well as have negative social and economic implications due to high recovery costs and limited investment opportunities in flood-prone areas. According to Mohamed, due to its tropical environment, Malaysia receives strong rainfall throughout the year. For the flood mitigation, according to the Department of Irrigation and Drainage (DID) of Malaysia, the structural measures in flood mitigation work refer to a choice of solutions by installing structures and implementing physical improvement works directly at the cause of the flooding. Knowing the exact values of flow rates required to operate the pump and gates of the storage facility is one way to improve the flood mitigation efficiency. Thus, a multi-objective evolutionary algorithm by using artificial intelligence software is needed to achieve the optimum values of the flow rates. MATLAB. MATLAB is the most used software program that has different artificial intelligence AI toolboxes that allow the user to apply them for their desired purpose with the least need for coding. Shaikh states that for prediction models, machine learning, signal and image processing, and other tasks, many researchers employ the MATLAB software. Models that will be developed to determine the optimal values of the flow rates are called neural network. Hence, MATLAB software will be used in this project to create artificial neural network models. The usage of the neural network is well known and famous throughout the world. Wunsch have applied the neural networks with the nonlinear autoregressive model at the southwest of Germany for groundwater level GWL prediction of several wells. The neural network was used for monthly GWL forecasting in the Suez Plain of Iran. It shows that the neural network is a great series of algorithms that have been a good choice for the development of artificial intelligence optimization models. Problem statement. The recent flash floods in Sungai BUNUS at Jalan Tun Razak in 2011 forced the government to speed up its effort to find a solution to the problem, as this is the main street leading into the city centre. The study is aimed at reducing the flooding frequency within the Sungai BUNUS catchment at the selected area around the online storage, ponds, and especially at the Sungai BUNUS diversion. The following study objectives are proposed to reply to the problem discussion that have been mentioned earlier. Firstly, to develop a machine learning that can produce the optimum flow rates in each subcatchment. Next, to optimize the input parameter for each subcatchment. Lastly, to analyze the performance of the proposed approach. The scope of the study includes the following. The study only focused on the catchment area of Sungai BUNUS tributaries and the flood history. Next, the data collection comes from the consultant report, annual daily report, PLC data, water level, and flow rates. Lastly, model will be developed using MATLAB software, which is Neural Networks Toolbox. Okay, now let us move to the methodology. Collecting data. The diagram depicts the system applied by the DID at each online storage. The system used is Obermeyer pneumatic spillway gate system, which operates based on the condition at that particular time. From this gate system, we will get the values of water levels from different scenarios and times. In addition, there are programmable logic circuit (PLC) sensors to determine the water level at the upstream and downstream that were installed before and after the gate. For analyzing the data, the value of flow rates will be analyzed by using a toolbox in MATLAB, which is neural network. A neural network generally is composed of a connection of nodes. The signal enters the input layer, pass through the hidden layers, and leave to the output layers. The nodes of a layer receive signals, process them, and transmit them to the next layer. It resembles the neurons association, which is the most important mechanism of the brain. This figure shows the flowchart of neural network. In this case, the data that have been collected will be used as the input signals of the neural network. The already known results that we want will be the output. So, the inputs will be trained by the neural network by adjusting all those weights and biases and minimizing the error throughout the training phase. Thus, it will be resulting in more accurate and optimum results. For the preliminary results, at the moment, there are no data of the flow rates from the DID, hence we can run the code by using the testing data. From this, it will determine the best values of the input by using a single layer of neural network. Table 1 below shows the input that has been used as testing data and the already known data as the correct output. In the software, it will load the input data, process it, and train the models to find the best value of weightage. After several iterations that we said, the models will generate the optimum output for the inputs based on the correct output that we appointed. From table 2, the neural network for those input has generated this output, which is almost equal to the expected result. Thus, the same concept but different layers of neural networks will be applied after getting the data of flow rates from DID for the upcoming results. These are the project planning throughout the final year project 1 until final year project 2. Project planning time is shown by the yellow colored shading, and while the actual current status is represented by the green colored shading. Lastly, if there is something which needs clarifying, I will be pleased to answer them. Feel free to contact me at my email or my phone number, and thank you for your attention. Have a good day.